Hi, my name's Ian, and I'm at my alma mater, Northwest Vista College. Not really that much of an alma mater. And I'm walking around behind our theater building and arts building to find something really interesting that might help people understand a bit more about the rocks in the San Antonio area. See, we have here a lot of limestone, and behind the theater building, there's a really beautiful limestone cliff. To me, and to many others, this is actually a very important feature on campus. There's plenty of limestone sitting around just on the ground out here, but there's only really one cliff wall that people can come to and observe different details about the geology of the area and its history. In these walls, you can see worm tunnels, you can see oysters, you can see layering throughout the millennia. So you can understand better what was happening in Texas, especially just right here, millions and millions of years ago, when Texas and this region was underwater. One of the first and more important details that we can find on this cliff wall is a long band of oyster shells, all in one single layer, that can indicate that there's a very possibility that this was a shallow ocean. This was probably less than a mile deep, and in fact this area was probably very sunny. One thing that this also indicates is there might have been a huge storm at some point that killed all of these oysters. What this layer demonstrates is that there was most likely a very shallow coral reef in the area, or a reef of some sort, that was able to provide food for these oysters in the form of materials like little particulate matter decaying creatures, mostly detritus. But it also shows that there is at some point perhaps a catastrophe that killed a lot of these oysters, probably about 90%. And how we get that indication is the fact that a lot of these oysters in the matrix have broken shells and were very likely not alive when they were buried. Now, right here is that oyster layer that I was talking about earlier and we had a nice close-up on. Well, that oyster layer is actually fairly low to the ground, as you can see here. And in fact, we have another large layer of very thick limestone. This is a lot of sediment that has been piled up on top of these oysters. And then on top of that limestone, at some point, there was a lot of silt that was piled up right on top of it, about a 3-inch layer. Now, we can assume that at some point in the past, that layer was actually much thicker, as well as this was. But over time, it's compacted. Now, a lot of all this material is limestones. Some of it is precipitated limestones, and some of it is sedimentary limestones, where the particulates have actually been worn off of other material and deposited later on, but didn't actually come out of solution in the water. So this material up here is probably the product of a storm sometime millions and millions of years ago, where inches upon inches of material was deposited on top of this big block of limestone that very possibly at the time was just slime. What we can see from this angle is all of the layers actually moving their way up from various forms of upheaval in the area. And in a lot of cases, it's actually just the material being pushed in odd directions by other material. You can also see how this oyster layer comes up here, and then another soot layer comes down this way, completely cutting off a big block of limestone. And then behind me, these older limestones are superseded by these oyster beds that were much lower on the wall back there. So we can see all of this material being moved up. Now, some of that could just be differential erosion and then sedimentation, but it's very likely that a lot of this was actually a product of upheavals further off that direction, miles and miles away, that created hill country in Texas. Another thing we can see is how the soot layer up there has actually been eroded away and moved down to meet with this oyster layer. And in fact, if you look closely over here, which I'll bring the camera over in a moment, you can see the last bit of the limestone that was a large block back there. One of the fine details that we can find in this rock wall are these worm boreholes. Now those worm boreholes will actually indicate to us that this rock right here was actually very soft at one point, and it made up an ooze or slime or really anything that you want to term it, where it would be something that would be goopy in your hands. Now the proper term is actually ooze, believe it or not. It was a micrite ooze, which was basically the liquid form of precipitated calcite. And on very rare occasions, you can actually find solid pieces of calcite embedded in this rock. One of the other features that we can see on this wall is the actual deposition of new material onto the old. Right here we can actually see that the water that runs off during the rainy seasons here in San Antonio will actually deposit new calcite material, crystals, and pretty much any other form of sediment onto the rock wall right here. What this tells us is that everything is constantly changing. None of this will ever stay the same. And all of this material has deposited ever since the construction of the building behind the camera. Right, guys. Well, I hope that educated you in some way, or at least if not educated you, at least it entertained you, and maybe enlightened you to something that maybe you didn't think about looking at. And that's rocks around your home. Sometimes they can hold some pretty interesting secrets that you wouldn't know if you didn't look.